So another proud NOAA member presenting on reprocessed SMOPS blended products from NOAA for soil moisture. Welcome, Jifu.
Thank you, Mike. So I would like to do a survey. If you know NOAA SMOPS, please raise your hand. 1, 2. So it seems I'm really need this presentation. So I'm going to talk about our SMOPS climate data record. It's actually a system from NOAA. So I'm going to sorry about that. So firstly, I will briefly introduce our SMOPS system. So yeah. So this is a web page from our SMOPS. We call it actually soil moisture operational product system. To meet the data requirements from National Weather Service as well as NSAP, we developed this SMOPS system. It called SMOPS instead of SMOP or SMOPS. Please remember that. So we can find here is actually for the real-time SMOPS. We actually, based on the SMOPS, we provide a one-stop shop for all available satellite soil moisture data products. So this allows us to make Michael's presentation more simple. So some people will ask the links for each individual satellite data product links or web page. Here we go. You just come here to find what you need. So what makes our SMOPS unique is the blended soil moisture data layer. We try to combine all individual satellite data products together so that we can generate blended observations. Here is the daily examples as well as 6-hourly examples. We can find the latency for daily is only 24 hours. But for the 6-hourly, the latency is pretty short. It's 3 hours. So that we can meet the data requirements for weather forecast users. In the past decade, we have already upgraded this system 4 times according to our users' feedback. But different versions probably vary significantly each other. So that's why we need to reprocess this system so that we can generate a long-term, consistent SMOPS blended soil moisture. Here is the flowchart. Basically, the advantages for this work, including we did intercalibrations between MC1 and MC2, brine temperature, so that we can use the optimal machine learning model to generate the final quality MC2 or MC1 soil moisture data products. We also use the SMAP as the reference data, as the individual satellite soil moisture data products probably vary significantly each other, including the climatology, data characteristics, or something like that. So we have to use the benchmark to do the bias corrections. So here we use the SMAP instead of the GeoDAS soil moisture simulations in the past, as well as the ESA CCR gas did. We also use the satellite observations, including snow ice flag, GVF observations as the quality flag, so that we make this system fairly dependent on satellite observations without involving any model simulations. So here is the the intercalibration results, we calibrated the MCE to the MS2. Actually, MCE stopped the operation in October 2011. But fortunately, the JAXA colleagues activated the slow rotation mode, so that we have about a 3-year overlap data between the MCE slow rotation and the MC2, allowing us to do the calibrations. Here's the correlation coefficients for the calibrated MCE and the slow rotation MCE and the MC2 bronze temperature for 6 gigahertz, 18 gigahertz, as well as 36 gigahertz. So that being said, we have already produced MCE and MC2 bronze temperature for the past 2 decades. If you are interested, please reach out to my group mate, Dr. Jifu Yin. Yeah, after that, we also try to select a machine learning model to refine MCE and MC2 source retrievals. As there are so many machine learning models, and they very significantly each other. So here we compared 6 commonly used machine learning models, including multiple linear regression, regression tree, random forest, GBM, SGB, as well as artificial neural network. We can find that the input data basically based on MC-E or MC2 observations, as well as the auxiliary information from soil texture, land cover, as well as the elevation maps. So this system also clearly depends on satellite observations. The same input data, as well as the same training strategy, as well as the same reference data, allowing us to highlight the model differences. Here's the estimation results. The CDF curves shifting to the left means better, while for the CDF for the training period is highlighted in solid line, while the dashed line indicates the CDF for the testing time period. The time period for training and for testing totally different, allowing us to do cross validations. We can find that basically the dashed line and the solid line overlap each other. That means all of the machine learning models can preserve the reference data information. So that we can predict operational source retrievals without retrain the model again in operational applications. So this is a very important feature for operational purpose. And we apparently we can find that the SGB model shows best performance in comparison with the other models. So based on the SGB model, as well as the calibrated MC-E and MC2 bronze temperature, we developed the MC-E and MC2 soil moisture retrievals. The top line is for the daily examples. From the left to right is for MC-E, MC2, as well as SMAP. We can find that the MC-E and MC2 can show the very reasonable spectral patterns in comparison with SMAP. And the bottom is for the zonal average. When the SMAP is available, basically the MC2 and MC-E overlap with the SMAP. But when the SMAP is not available, the MC-E and MC2 can still show the patterns back to 2002. So another advantage for our SMOPS CDR, actually SMOPS climate data record, is using the SMAP as the benchmark. Here, except the MC2 and the MC-E, we also did bus correction of the other individuals, including SCAD A, SCAD B, as well as SMOPS to the SMAP using the CDF matching method. The dashed line is for the original individual satellite observations. The solid line is for the observations benefiting from the bus correction. We can find that the CDF curves can much closer to SMAP CDF. That means the bus correction are very successful. As such, the CDF match the SMOPS CDR, CDF is basically overlap with the SMAP. So we also compared the SMOPS CDR with the reference data on SMAP. The left column is for the daily examples for SMAP and the SMOPS CDR. It's very interesting to find that basically the wet, we can find that the SMOPS shows the wet patterns in the wet area, I mean the forest area, and the dry patterns in the semi-arid or desert area, basically respect to the SMAP very well. But the spatial coverage is pretty high in comparison with SMAP. The right side is for the correlation coefficients between SMOPS CDR and SMAP. The sample density area shining in red color is much close to 1 black line. That means the SMAP and SMOPS CDR are exactly same. While the blue area means the SMOPS CDR and the SMAP sample size, sample density departing from the 1 line. But basically, we can find that the SMOPS CDR and the SMAP match each other very well. So probably you will ask a question. Given SMOPS CDR and the SMAP match each other so good, and we already have NASA SMAP, why we still need the SMOPS CDR, right? So this is the answer. This is a special coverage, or we can say data availability. Firstly, the revisit time for SMAP is about 2 to 3 days. So, but for our SMOPS CDR highlighting in the red dots, the spatial coverage is greater than 95%. And the time period for SMAP is pretty short. That's starting from 2015. But our SMOPS CDR come back to 2002. Here is the validation results based on the NOAA US CRN, as well as USDA scan, as well as NSMD. We have to say that it's very helpful with these high quality in situ observations, and keep running this program are very important for our validation purpose. So we can find here the difference in correlation coefficients, difference in root mean square errors, and the difference in unbiased root mean square errors between the SMOPS CDR and the SMAP. Compared to the SMAP, the SMOPS CDR shows a little bit worse correlation coefficients, but basically equivalent performance in for the root mean square error and the unbiased root mean square error. And the corners domain average root mean square error is 0.084 for both SMOPS CDR and the SMAP. For the unbiased root mean square error value is 0.067. They are still same. The time period for this kind of comparison actually is from 2015 to 2022 when SMAP is available. We still want to see a long time period for our SMOPS CDR. Here we go. It's the statistical for the whole time period. We can find that benefiting from the reprocessing, all of the individual satellite SOMS data products shows a much better performance with greater correlation coefficients, much lower root mean square error and unbiased root mean square error. As such, the SMOPS CDR shows a very reasonable performance over the time period from 2002 to the most recent. We have already upgraded to our SMOPS CDR to the most recent, actually June 2024. So given the long-term consistent SMOPS CDR, we will consider about how to use, how to apply this kind of data products. So here is the long-term climate change patterns for the global domain. So we cannot do this kind of investigation if we don't have a long-term consistent high quality climate data record. Apparently we can find that the global, the whole global shows dry patterns in the past 2 decades. And it's very significant. It can reach to 0.002334, something like that, but it's still very big. It's about actually about 1% or 1.2% relative to the average soil moisture values. Another application is for the flooding. It's an example for Harvey hurricane. Harvey hurricane, here we can find the pink cross is for the Houston city, and the star shows the Harvey hurricane location. The red color star in red color means the heavy storm. In pink color means the light storm. We can find that once the Harvey hurricane landed Texas area, the anomaly for SMOPS CDR becomes much higher, can reach to 0.4 in volumetric unit. It's very huge for surface soil moisture. Basically, when the hurricane stay in that area, SMOPS show much blue, keep showing the blue area color in that area. That means there are very severe flooding event occurred over there. When the hurricane move toward the east or northeast, we can find that the blue color gradually gone. That means the flooding basically gone and become to back to normal surface soil moisture conditions. As well as we can also use the SMOPS CDR to do drought monitoring. We compared with the SMOPS CDR and the USDM in the past 2 decades. Basically, the SMOPS CDR shows a very similar patterns with respect to the USDM. Okay, here is my summary. I don't want to repeat it too much. Basically, if you are interested to our SMOPS, here we go. We have the links. You can download the data from NOAA FTP. You can find the data from NOAA OSPO. You can access that data to NOAA class. Okay, thank you.
What's the resolution of this product?
The special resolution is quarter degree, 25 kilometer. Actually, we are developing 1 kilometer downscaling SMOPS CDR. Our preliminary results show, very promising. Hopefully, we will release that kind of high resolution SMOPS CDR by the end of this year. So.